Here are a few more complicated examples. Now, we have in this example the half-life of iodine 131. It's a radioactive waste from the nuclear power industry, and it has a half-life of 8 days, after which it decays to a form that's not radioactive. Suppose you have 70% of this substance. Now, let's talk about half-life. Half-life is what scientists use to measure radioactive um, products. We talk about how long it takes for it to become half of the weight that it originally is. Now, in this case, it takes us 8 days for it to be reduced. So we would have initially at 0 days, 70 grams for the weight. Now, after 8 days, this becomes half. And then again, after another 8 days, the 35 is halved to 17.5. Now, I have it again, and that would happen at 24 days. Now, you see that this only happens once we've hit 8 days. If we don't have 8 days, then one cycle of getting to 50% has not happened. Now, as a result of that, we need to express our time as a fraction. It's going to be a fraction of 8 days. Now, let's sort out the information. We have y, which is the value, the total value, weight of the iodine 131. A is the original amount, 70 grams. B is our decay factor. We know that half-life means decaying by half. So 100 minus 50 is 50%, 0.5. And finally, our x is a fraction out of 8. We're going to make x equal to the number of days divided by 8. So, for example, if we've only gotten 1 day, we haven't gotten to 50% yet. It's only a fraction. It's going to be 1/8 of the 50%. Now, when I write this equation, I'm going to have y is equal to 70 times 0.5 to the power of d over 8, where y is the weight of iodine 131 and d is the number of days. So how much iodine 131 is left after 32 days? We're going to substitute it into the equation. Y is equal to 70 times 0.5 to the power of 32 over 8. Let's throw that into the calculator. 70 times 0.5 to the power of 32 over y is equal to 4.375 grams. Another example here. Caffeine in your blood is halved every 6 hours. Write an equation to model y, the percent of caffeine in your blood, x hours after having the caffeine. So let's sort out the information. Now, the fact that it says this is halved every 6 hours will give us a clue that when we do our x, we're going to have to represent it as a fraction. Now, we know that y is representing the percent of caffeine in your blood. A is the original amount. Now, this one, like the example with the blue jeans, there is no number that we're starting with. So, for us to represent 100%, I'm going to use the number 1. B represents the decay factor, and since we're talking about half, I'm going to have 0.5. And finally, with our X, we know that one cycle for it to be halved happens every 6 hours. So if it's less than 6 hours, it's going to be a fraction. Let's take number of hours and divide it by 6. So the general equation for our situation, we have y is equal to 1 times 0.5 to the power of h over 6, where y is the percent of caffeine in the blood and h is the number of hours after ingesting it. Now, what percent is left in your bloodstream after 10 hours? Let's put this into our equation. 1 times 0.5 to the power of 10 over 6. Enter this into the calculator. 1 times 0.5 power 10 over 6. So we have y is equal to 0.31. And this is the percent, but represented as a decimal. Okay, so let's convert to percent. We're going to multiply it by 100. So we could say 31% of caffeine remains in the blood after 10 hours. Now try these questions on your own. See if they work out for you. Both of these questions will have x's where you need to express it as a fraction. When you're finished that, please look at the practice questions. You're going to write a general equation to model the situation. Define your variables and remember to sort out your information. Then you're going to solve the question. So on the last slide, the answers are there.